Hi, welcome. If you're new to the channel, I'm Dr. Denise, a professor in human AI interaction. I research how we build, interact with, and ultimately trust AI systems. Today, we're discussing a counterintuitive but powerful protocol using AI to identify and quantify human bias in text. Usually, the conversation around AI and bias is framed as a glitch or failure. But if we look at the research, AI is fundamentally an automated mirror. Research shows that technology reflects the knowledge and implicit biases of its creators, which is eventually us. As an engineering professor, I see this as an opportunity. If an algorithm is too good at picking up on human prejudices, we can use that same mathematical sensitivity as a diagnostic tool. We can use AI to audit human history. And today we're going to look at the mechanics of word embeddings, the genderify failure as a diagnostic lesson, and specific engineering protocols for building an ecosystem of trust. I'm going to explain all these terms in this video. Regardless of your technical background, there's a specific advantage to looking at these systems through an engineering lens. As a professor of human AI interaction, I see it as a core part of my mission to move these conversations out of the lab into your hands and hopefully equipping you with the exact protocols needed to identify and audit algorithmic biases in your own life. Let's first talk a little bit about the physics of text, word embeddings. What does that mean? To use AI to find bias, first, we need to understand how AI reads. It doesn't see words, it sees vectors. In natural language processing, or NLP, we use something called word embeddings. More than 10 years ago, during my PhD research on semantic analysis on language models, I was looking at how to map language into a multi-dimensional space. Let's look at a high signal case study of a failure that actually taught us how to audit a system. Research shows that a specific AI service called Genderify was designed to identify gender based on names and titles. That is the term that researchers coined or introduced to identify gender based on names and titles. The moment you add the title to doctor to a female name, we call it a failure. So, the researchers use this to demonstrate how word embeddings in AI can be mathematically biased. They show, for example, in one of those research that AI identified Megan Smith as a woman with high confidence, but the moment the title doctor was added, the AI flipped its prediction to a man. The AI revealed that its training data, essentially because historical data has a higher frequency of men being referred to a doctor. The AI learned that the title doctor, was a stronger indicator of being male than the name Megan was being female. But as an engineering professor, I see that as a diagnostic breakthrough because if an algorithm is too good at picking up human prejudices, it means that we successfully build a mathematical sensor for our own history. So we're not asking the AI to be a judge of what is right. We're using the AI as a black light to reveal the stains in our data that have been invisible to the naked eye for decades to us. Research shows that AI calculates the mathematical distance between concepts. To explain what distance means, I can use the concept of a mental map, but more like with the GPS coordinates. In AI, every word or concept is assigned a specific set of numbers or vector. These numbers place the world in a massive multi-dimensional space. The logic is that the AI assumes that the words with similar meanings should be neighbors in this space. The math behind it to understand a word, and the AI calculates the cosine similarity, essentially the measuring straight line distance between 2 points. So the problem is that the AI or AI's map is built from biased text. It places doctor closer to man than woman. And as an engineer, I look at this as a geometric displacement. If doctor is mathematically neighbor closer to man, it's not just a random guess, it's a coordinate error, going back to our GPS metaphor, based on this biased historical map. So in a neutral model, the vector for women to men should be equidistant to the vector for queen to king, right? However, research shows that when we audit large-scale models trained on human text, the AI reveals a compressed prejudice, which means that the AI has taken millions of subtle, messy human biases and squeezed them into a single high-density mathematical concept rule. The mathematical distance between men and computer programmer is often much shorter than the distance between a woman and a computer programmer. The reason researchers care about this is that it proved AI is not just making random guesses, it proved that the AI's internal map of the world had a hard-coded link between high-status professional and male. And if we don't identify that, we're essentially building tools that automate the glass ceiling. By using adversarial testing, where we intentionally change one variable like a title to see if the AI's output changes, we can use AI to map out the hidden rules of human society. Research shows that this kind of algorithmic auditing is one of the most effective ways to reveal sociotechnical bias before it causes a real-world harm. By the way, this is not just a hallucination. This is not a hallucination. I teach my students this as the following. In engineering terms, an hallucination is a factual error. The AI is making up a person or a date or information that doesn't exist. Bias, on the other hand, is a consistency error. The AI is actually being too accurate to the flawed historical data it was given. By analyzing these, as we mentioned, cosine similarities, we can scientifically quantify exactly how biased a specific culture or data set is. We aren't guessing if a text is sexist or unfair, we're measuring its geometric displacement. So as an engineering professor, I distinguish between these two because they represent fundamentally different failures or failure modes in the architecture of large language models. I like to use this GPS metaphor actually. So think of it like a GPS system. A hallucination is when the GPS claims that there's a bridge when there's only water. A bias, on the other hand, is when the GPS consistently directs you to the most expensive tall roads because it was trained on the data from a luxury car service. Let's take a look at the hallucination in a little more detail. In technical terms, a hallucination is a stochastic failure. What does that mean? LLMs work by predicting the next most likely token or the word in a sequence. Sometimes the probability map leads to the AI into a creative but false direction. So basically, the mechanism of hallucination is that the AI is essentially dreaming based on statistical associations that aren't tethered to the ground truth database. And of course, the result is that it invents a citation or it invents a legal case, a historical figure, or just a random person. It is confident, but it's actually factually wrong. Consistency error is the bias. I know people are complaining about AI hallucination, and I discuss this with my students all the time. In my opinion, bias is much more dangerous than hallucination because it's not a glitch. It's the feature of the training data. The AI isn't making things up so that it can be fixed later. It is being too accurate to the flawed history. So the mechanism is that it is a systemic weight error. If 80% of the text that AI read during training associates CEO with men, then the AI creates a mathematical rule that men is most statistically probable neighbor to the CEO, the word CEO. The result is that every time you ask for a story about a leader, it chooses a male character. It isn't a one-time mistake or an error. It is a consistent, predictable pattern. And the fix requires algorithmic auditing and statistical debiasing. We have to manually adjust the weights of the vectors or provide more diverse data to break that consistent prejudice cycle. And why this distinction matters? Why did I explain all these differences between a bias and a hallucination? Because if you treat bias like an hallucination, you'll try to fix it by giving the AI more facts. But the facts of our history are biased. You can't fix the biased AI by giving it more history. You fix it by engineering a filter that recognizes when the history is repeating a prejudice. A hallucination is the AI losing its mind, but the bias is AI losing its objectivity. Let's now take a look at the ecosystem of trust. So, how do we contribute to a solution using these tools? Research by Nadim and others published in 2022, where they emphasize that we cannot have a functioning society with AI unless we build an ecosystem of trust. So this isn't a vague feeling, it's a technical requirement, they argue. We need to move forward to an ecosystem of trust. This isn't a vague ethical goal, they emphasize. It's a specific engineering architecture composed of policy and accountability and technical rigor. We have to move away from the idea that AI ethics is just a feeling or a social goal. From an engineering perspective, it's a trust issue. A trust is a functional requirement of a system, and if a user doesn't trust the output, they won't use the tool, or worse, they will use it incorrectly, and which can lead to a systemic failure. In the research specifically, they look at the ecosystem of trust frameworks in the 3-pillar architecture, which is designed to ensure that the AI remains a reliable partner in human decision making. So the foundation of trust is accuracy. If the machine is consistently biased, the signal is corrupted, right? We use statistical debiasing. Once our AI has identified a biased vector in our text, we can mathematically neutralize the dimension. Research shows that we can project these embeddings onto a gender-neutral subspace, effectively forcing the AI to ignore gender as a predictive feature for professional roles. How does it work? How does statistical debiasing work? Engineers use mathematical techniques to neutralize biased vectors in word embeddings. For example, forcing the mathematical distance between the doctor and the man to be exactly the same as the doctor and woman. And the goal is to ensure that the model's internal map of the world is as objective as possible before it ever reaches a user. And the second pillar is an operational pillar. Algorithmic auditing. What does that mean? Trust requires verification, they say. You cannot simply set and forget an AI system. You must treat it like a piece of industrial machinery that requires regular inspections. Second, we implement algorithmic auditing via human in the loop. Research shows that having a human expert perform the sanity checks on an AI-generated flags is cited in 23% of the literature as the most effective mitigation strategy because it creates a fail-safe where the AI identifies patterns but the human validates the context and prevent the genderify type of automated errors from causing real-world harm. And third pillar is a social pillar. Diversity as a technical variable. Trust requires perspective, they argue. This is the most overlooked part of the engineering process. Research shows that the increasing diversity of the development team, a solution cited in 30% of the studies, directly changes the subjective inferences made during the design phase. And a diverse team is more likely to spot blind spots in the training data like default male bias in medical or crash test data, for example, before the model is even built. So why this matters? Like, why do we care, right? Again, as a professor, I believe it's my mission to explain that the trust is not like a switch, like a binary switch. It is a calibrated scale. We need to calibrate it. Whether you're an engineer or not, whether you're an AI person or not, you need to hear this from a technical perspective. If any of these three pillars fails, the entire ecosystem collapses. And without the technical rigor, the AI is just like a super fast machine, a biased machine. Without auditing, the AI is like a black box with no accountability. We don't know what's going on inside. And without the diversity, the AI is just like a narrow, tiny mirror that only reflects the world of its creators. So when we build an ecosystem of trust, we aren't just fixing a bug like we would fix a hallucination. We're actually engineering a society where technology amplifies human potential rather than automating human prejudices. I repeat itself. So if your team understands the nuances of data, they're better at building the filters that catch bias, for example. But the reality of current technology is that these industrial filters are still work in progress, and you cannot wait for the perfect algorithm to be shipped to your device. And this brings us to a critical shift in our discussion: how non-engineers identify bias in daily life. You don't need to be an algorithmic designer to audit your AI you use every day. So let's talk a little bit about how non-engineers identify biases in daily life. If you use AI for writing, searching, or generating images, you can identify bias by using a protocol called adversarial probing. So here's how this could be useful for your day-to-day life. First, the swap test. If you're using a translation tool or a chatbot to write an email or a story, try swapping the pronouns. For example, translate a gender-neutral phrase from a language like Turkish, for example, which the word o for her or she into English. So there's only one word for he or she in that language. What to look for is that does the AI consistently translate they are a doctor or bir doktor in Turkish as he's a doctor, or they are a nurse as a she's a nurse. So why is it useful? Recognizing this helps you avoid sending out documents maybe that inadvertently reinforce stereotypes or misgender your colleagues. And if you use AI image generators, for example, like DALL-E or Midjourney for presentations or like social media, look at the default results for professional roles. To test, you can ask AI to generate an image of a CEO or a person working in a lab. And what to look for in this case is according to research that these systems often produce a default male or specific ethnicity for high status role. So by doing that, it helps you become a more intentional curator. By noticing the bias, you can adjust your prompts. So you can say, for example, generate an image of a female software engineer to ensure your visual content is inclusive and representative. And third step is identifying gatekeeping bias for personal finance, for example, or hiring. While you can't see the code behind the bank's loan algorithm or company's hiring filter, you can look for inconsistent outcomes. If you and your partner, for example, of a different gender have similar credit scores or professional backgrounds, but receive vastly different automated results like credit limits or job ad targeting, that is a signal of a bias. And understanding that AI is not objective allows you to advocate for yourself. If an automated system denies you a service, knowing that these systems can be biased gives you a standing to ask for a human-in-the-loop review where a person, or not a machine, a person makes the final call. The most useful way to think about this is to treat AI as a high-speed mirror of our culture. When the AI shows you a bias, it is actually revealing a shortcut that humans have used for decades. By identifying these shortcuts in the AI, you become more aware of these systems in your own decision making. And you stop seeing the AI as a source of truth and start seeing that as a signal of the biases that still exist in our professional and social history. Now we need to address a fundamental truth of linguistics and data science. Language is not neutral. And as we've discussed, text is a high-speed reflection of cultural norms, the power structures, stereotypes, and historical patterns. If the text contains bias, the AI learns that bias as a mathematical rule. It's that simple. But to audit a system, we need to know exactly what we are looking for. And in the research, we categorize bias in text into 4 technical buckets. First, there's a representation bias. This is a question of who is present in the data and who is missing. In many of the data sets we use to train large language models, the default engineer is almost preferred with masculine pronouns. Research shows that when a model sees engineer thousands of times, it builds a statistical association that effectively erases women from the professional vector. Second, we look for descriptive bias. This is about how different groups are described. Research shows that in performance reviews and media text, men are more frequently associated with agentic words like analytical, decisive, or ambitious. Women, on the other hand, are often described with communal words like helpful, kind, supportive. To a machine, these aren't just adjectives. They're weights that influence how it ranks candidates or suggests content. Third, we have a prescriptive bias. This is the should factor, what people are expected to be. This is where we see AI struggle with gender roles. Research shows that AI often expects women to be nurturing and men to be assertive. If a woman in a dataset acts assertive, then AI might flag that as an outlier or an error because it violates the prescriptive pattern it learned from the historical text. Finally, there's the visibility bias. This is about who gets highlighted versus who is pushed to the background. Think about media coverage. Research shows that the text about women often focuses on appearance or marital status, while text about men focuses on achievements or expertise. When AI processes this, it learns that the appearance is relevant to the feature for one gender, but not for the other. But as you see these tools, remember that the goal is not simply to prove bias exists. As engineers, as researchers, as global citizens, our goal is to investigate patterns and question assumptions. I will be very clear on a technical distinction here. AI is not a bias detector. It is a pattern detector. It detects patterns, okay? We have to be careful because the AI itself has limitations, and research shows that AI might overgeneralize, it might misclassify words, or it might completely ignore the context of a sentence. Most importantly, it will always reflect its own training bias. When you use a prompt like analyze this text for potential gender-coded language, you aren't just getting an objective truth. You're getting a report on how that specific model's mathematical weights react to your input. Now you're seeing the problem like an engineer. You aren't just like looking for bad words, you're looking for the structural signals in the data architecture. To wrap up, we have to stop seeing AI bias as a bug to be deleted or fixed. I believe that we should see this as a high-resolution signal. Algorithms are designed to discriminate and predict, and they sort, they classify, they make inferences. The problem is that when these systems are trained on historical data with inherent biases, those prejudices become part of the solution. But by using the tools of semantic analysis and adversarial testing, we can turn the AI into a filter that catches those prejudices before they reach to the real world. Research shows that this is not just a technical glitch, this is actually a socio-technical phenomenon where the code and the context are inseparable. If you found this technical deep dive valuable, consider subscribing, consider reaching out to me if you want to dive more deeper into those topics. I'll see you in the next protocol, in the next episode. Thank you.